Hello friends! Today we'll continue the attempts of classifying the element. In the last video we already talked Mendeleev's periodic table, Moseley's periodic table, and so today we'll continue and take modern periodic table. Let's see together what does happen in the modern periodic table because it was the last table. Look here. There was a scientist called Bohr. This scientist discovered that there are 7 energy levels for the atom. This energy level, if you remember, are what we distribute the electrons on. If we want to put the electrons, we don't put them in a random way. No, we put them in a definite way. These ways are called energy levels. And so Bohr said that the maximum number of energy levels that's used for any element is 7 energy level. There are no more than 7 energy level. Whatever happened or whatever the largest of the element, no more than 7 energy level that we can use. Okay. And he said also that for each level of them there are sub-levels. So he said the 7 levels are called main energy levels, and there are inside each one of them energy sub-levels, as you can see here, for example, but you don't have to consider it. For the second level here, number 2, can you see this? We have S and P sub-level. We have S and P sublevels. For number 3 here, we have S, P, D sublevel, and so on. So he discovered the main energy levels are maximum 7, and for each level there are energy sublevels. We said in the Mendeleev's periodic table we arranged the element according to atomic weight. Very good. And for Moseley's periodic table, we arranged the element according to atomic number. In modern periodic table, we consider 2 things: atomic number and also the filling of the energy sublevels. We considered here the energy sublevels. So we arranged the elements according to their atomic number and according to how can we fill the energy sublevel with the electrons. Finally, we have this periodic table, as you can see here, this large periodic table. Now we finished the 3 attempts of classifying the element: the Mendeleev's, the Moseley, and modern periodic table. Mendeleev's arranged the element according to atomic weight, Moseley according to atomic number, and Bohr, but we cannot say Bohr because there was many scientists who made this modern periodic table. They arranged the modern periodic table according to atomic number and the way of filling the energy sublevels. After we finished this this element classification attempts, let's talk specifically about the modern periodic table. Look here. Here, this is the modern periodic table, the last table made by the scientists. Now we want to describe this table. What's happening here? What's this period? I can't understand anything from it. There are many colors, many elements. What's happening here? Look here. Come with me. At first, how many are the groups that made in this table? And we said groups are the vertical row, they are groups. And how many period are there? We said period are the horizontal row. If you try to count them, you will find that we have 18 vertical group and 7 horizontal group. 18 vertical group and 7 horizontal groups. And for all the periodic table we have 4 blocks. like we have 4 blocks or we have 4 homes, and we put the element on these homes. Let's see how can we put the elements with the home or in the home or in the block. How can we do this? Or why did we put some elements in the left, some elements in the right, some elements in the middle? Why does it happen? Look here, let's see each block of them. The first block is S block. This is S block. And the left one, this is S block. If I asked you where is the position of the S block, it's so easy. As you can see, it's present in the left of the periodic table, in the left side. And how many groups for this block? Perfect, 2 groups. A, 1A and 2A, or 1 and 2. And what is the letter of this block? Or how can I classify the element of this block? They take the letter A. So if I told you there are elements in block 1A, you know that it's present here in the first group. That was S block. Number 2, it's called B block. And it's found in the right side of the periodic table, as you can see here. So if I asked you again, where is the location of B block, you will say on the right side. How many groups does it have? Count with me. 1, 2, 3, 4, 5, 6. So it has 6 groups. And they also take the letter A. So I can say 3A, 4A, 5A, and so on. But except the last group here, it's not called 8A. It's wrong. It's called 0 group. 0 group. We cannot say A here for the 0 group. All what I said now about the letter A, it's called a traditional name or a traditional way in calling the groups. Because in the modern way, we just say 1, 2, 3, 4, 5, 6, and so on. We don't use letter. So this way is when we use the traditional way in saying the group. Again, S block in the left side, B block in the right side. S has 2 groups, B has 6 groups, and both of them take the letter A except 0 group, which is noble gases. Block number 3 is D block, and it's found in the middle of the periodic table. This is the D block elements. Where is the location of it? In the middle. And they have a specific name, which is called transition element. They are called transition elements. How many groups for this block? Count with me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 groups for the D block elements. Okay, what is the letter here? It's not A, like S block and B block. It's B. B. So I can say 3B, 4B, 7, 5B, and so on. And there is an important note here. As you can see here, this transition element or this D block didn't start from the first horizontal row. They started from how many? Look, 1, 2, 3, 4. They started from period number 4. So if I asked you, does it found from the beginning of the periodic table from the first horizontal row? No, from the 4th horizontal row. They start or they appear from period 4. And it starts with 3B, not 1B. 1B come in the end. Look, 3B, 4B, 5B, 6B, 7B, 8B, and here is 1B and 2B. Why does it happen, Miss? Because we said when we distribute the element in the modern periodic table, we considered 2 things: atomic number and also the filling of energy levels. Do you remember this? The levels filling is considered here. So look with me. Look here. if we talk the first element here in the first period, which is scandium 21, let's distribute the electron. Let's make the configuration, electronic configuration. In the first level, we will put 2 electrons. In the second one, a electron. And the third one, a electron too. And in the last one, 3. Okay, because 2 plus 8, 10, plus 8 again, 18, plus 3, 21. So the last energy level has how many electrons? 3 electrons. Let's make the electronic configuration of the copper here in 1b. We'll take in the first level 2, 8, 18, and in the last level we will put 1, because when we count them, 2 plus 8, 10, plus 18, 28, so we need only 1 electron. So tell me again, how many electrons for the last energy level? 1. So that we called, or we put the name of the first group in the D block as 3b. 3 here because the last energy level has 3 electrons, and here 1b for copper because it ends with 1 electron. I think now you know 2 things: why we started with 3b, and why, or what's meant by distributing the element according to the filling of energy level. Let's continue. So it was block number 3, which is D block. Again, it's found in the middle, called transition elements, has 10 groups, and take the letter B, except group 8. Look, 3b, 4b, 5b, 6b, 7b. We had here to say 8, 9, and 10b. No, we didn't do this. We take all of the 3 groups as 8 group, or as 8b, or it's called 8 group, not 8b, 9b, 10b, and so on. It's exception here. What about the last group, or the last block? Last block is called, let me read this, give me a second. Last group is called, or last block, sorry, is called F block. Where is exactly the F block? Look, it's found in below the periodic table. Do you remember when we said that Mosley put the lanthanides and actinides element below the periodic table? Yeah? We called this 2 groups or 2 periods of lanthanide and actinide as F block. And they have only 2 things, lanthanide and actinide. That's all about F block. They don't take literal like the rest of elements. Let's summarize all of them here. So again, we have 4 blocks. S block, in the right side, in the left side, take letter A. P block, in the right side, take the letter A, except 0 group. D block, in the medium, and take the letter B, except group 8. F block, below the periodic table, and they are lanthanides and actinides. Thank you so much, and if you have any questions, leave it for me in the comments. See you in the next video. Bye bye.